Okay. So good afternoon, everyone. Welcome to the SDL tea time this year. And for this summer, we're gonna have a 45 minutes tea time from 2:30 to 3:15 every Tuesday to Thursday. And we're gonna talk about the basic information of data science. And so thanks for coming. And we hope we can enjoy the summer with different topics and codes. So today I'm going to talk about the introduction of Git, Vim, and Latex, which is going to be very useful for the future topics and also the future work. And for the first thing I'm going to talk about is the introduction of Git. Before the Git, I'm going to talk about the version control system first. So the version control system is used to track the control the change of files, and it enables multiple people to work simultaneously, work on a single project. And each person can edit his or her own copy of the file and choose when to share those changes with the rest of the teams. And the version control system can integrate work done by different team members, and in most cases, edits to the different files or even the same file can be combined without like losing any works. And the other advantage of version control system is it gives access to the historical version of your project. For example, if you make the mistakes, you can always roll back to the previous one. So that's going to be very helpful for the people working in our lab. Some of us may work on the same projects and or we have the same aim or targets. In this way, we can work on the same repository and to share our code with each other. And also, if we find the current code is not as good as the previous one, or we find some bugs, we can always go back to the previous version and to fix those things. And the basic structure of a version control system contains the two parts, as shown here: a repository and a working copy. The working copy is where you do your local edits or changes on your own computer. So you can make arbitrary edits of your files without like affecting other people working on the same project. After you finish your work and you're happy with those edits and you want to share those edits with other team members, then you can commit your changes and push your the edits and the files to the repository. And once other people can update their own working directory, then they can see those updates and the new versions of those files. So the repository, on the other hand, is a database that's all the edits or the versions goes to. It contains I think most of all the historical versions of your projects, and we call this as a snapshots, especially for the Gits. And it's also possible for the repository here that contains some new version or the changes or the edits that hasn't been applied to your own working copy. When you want to see those new updates, you can update your working copy and gauge those and see the changes from your team members. So for a repository, it basically has two different structure. First, the simplest case is we call linear history. That the changes is made after the previous one. Another possibility of the repository is that they have different users. They work on the same projects, and they also add the same the work simultaneously. In this way, then we have a split timeline and history and version, and then those can be split and then merge again. So the type of version control system, basically, we have two types. One we call the centralized, another one is called distributed. So from these two diagrams shown here, I think quite clear for us to see. That's the main difference between the centralized and distributed version control system is the number of the repositories. For the centralized repository, where you only have one repository on the cloud. For the distributed version control system, besides the central repository on the cloud, you also have your own repository on your own local computer. And for the people they work with the centralized version control system, once you commit your edits or the changes to the repository, and other people can update their repository to see those changes. However, for the distributed version control system, once you commit your changes to the repository, other people still won't have the access to see your changes until you push your changes to the central repository on the cloud, and then they can pull those changes and then update their own working directory. So in this way, they're gonna need to do the 4 steps to see the to do a combined or integrated work. So in general, the distributed version control system runs faster and have more features, which also have less probability to crash. But it's also somewhat kind of complex to be understand. But once you again start to use those, you're gonna find it's quite useful. And we're gonna show a popular distributed version control system. That is the main topic of today. It's called Git. So the Git is I think is kind of the most popular distributed version control system right now, and it's being adopted by a lot of software development companies. And it makes contributing to the open source and teamwork as easy as you can just work to a part. And if you are a software developer or you're writing the code, you're definitely gonna know this. So it has advantage of fast and efficiency like other distributed version control system, but it also has the key features of its own. As we said in the slide, you can need to 4 steps to see those changes in Git. When you want to pull the updated, you only need one command line to perform both pull and updates. It can be more convenient and fast and can save a little bit of time. And another part is the Git has a third crucial part called staging area, which is different between the distributed version control system diagram I showed here. In this way, with this staging area, you can slightly choose which changes you want to share with your team members and which you're still working on and do not want to show those yet. So with this diagram, we can show the local workflow, what's the local workflow look like. So after you've done some edits or create some new files and have some new ideas, you change your file, and you can take an overview of what you have done for your working directory and select those changes and edits and add them to the staging area. And then you can make a commit and do this command line and then commit your changes to the local directory. And after this, you can also do the same thing, git push and push to the centralized repo on the cloud so people can see those changes. And as I said previously, that Git is quite useful for people to work together. And I think the main feature to achieve this is Git has called the branch. The branch is like I showed here. You have this line represents the timeline. When you create a branch that you start a new project and you want to do something good for this, and then you can always make edits and make a commit, those circles represent the commits you made for this timeline. And if you have something new idea you want to try, but you don't want to destroy your current work, or that's going to be isolated from the current work, or some for the other cases, multiple work together and they want to be isolated, then they can have those multi-branch, like the figure showed on the right. The default branch is called master branch. That is the main branch, and we in our lab we just keep it as the most stable branch. And also, people can have their own branch and try different things. And the commit you made for each branch is isolated from other branch. That means if you are in this branch and what you have done and the files or changes won't interfere other files in other branches. They only, and the people they work on the other branch cannot see those files in this branch, only if you merge them into the same branch. The merge actually to combine to update the commit to the target commits. And in Git, it has a different algorithm to do the merge. On the left, I show the first one is called fast forward merge. That is in the condition that you have a linear path from your current commit to the target commit. Then you can do a merge command that's gonna move those commit to the update to the latest updates, and then you can get the new stuff from this commit point. And another thing is that in most cases, people they don't have this linear pipeline, but they work in different branch. And in this case, it's gonna use a three-way merge to merge the two branches, and they have the same ancestor to the same to the same timeline, like I showed here. And this has a problem when sometimes when two people they may simultaneously change the same part of the same file, and in this way you're gonna have a merge conflict, and the Git will stop working until you solve the problem manually. And I think in our lab we have this problem quite often, and in this way, the most like the common thing we do is to show the two conflict files together and choose the one you want. And so I think after we talk about the basic information of Git, then we can have people to try to really use the Git in their own computer and to try to feel how it works. And in this slides, I put some link that's where you can download the Git, and also it has a tutorial to teach you how to install the Git on different computers with different operating systems. And also I put some links here that's where you can go to if you have some problem with Git, or you want to learn more about Git and the problems. So in the next few minutes, we're gonna show how to use those in person. And before this, I'm gonna show how to use the Git in your own computer. After you install the Git, you're gonna find you have different tools to use the Git. We have a command line interface, which you can run all the Git commands there. And also we have the GUI, that is graphic user interface. It's more prettier. It's also do the same thing with the command line, but we're gonna still recommend people to use command line interface to do, because that's the most developers does. And also I made some commonly used commands you can use when you're using command line interface to do Git and to learn the command line. And I also put the cheat sheets for the Git and the command line in this folder. Once you got this topic materials in our SDLET time folder, you're gonna find those there. So I think right now I'm going to show a simple demo of how to use Git. Because I'm using I'm using a Windows computer. I already installed the Git here. I'm gonna open the Git bash. Here's what it looks like when you first open the command line. And the first thing I want to do is to show where am I right now. You can use print your working directory to show here where I am. And also I can use ls to list on what do I have in the current directory. And usually I don't store all the files together and we separate them into different folders. For myself, I store all the things in the document folder. So I use the CD, means the change directory. Go to this document folder and also show what do I have in this folder. And as an example, I can also show what do I have on our traditional way. So in the documents folder, as you can see from Amber Alert. Okay, so here on the left of the screen, you can see this is what's shown on my document folder, and this is the real. Computer side. Better? But now we're going to kind of see this. Okay. And then here you can notice that I have a folder called Git. That's where I put all my repos there. So in our lab, we have a cloud repository called Bitbucket. That's also where this SDLET time folder is. And I think Ahmed already made this like a free, and everybody can have access to this folder. And when you find this, it's called 18 SDLE in SDLET time. And then this is what it looks like from the Bitbucket and from the cloud. You can notice there is called a clone, and you can click this. This gives you a command line that you can use to copy and paste on your command line interface. Here I can click the paste and go to my the command line interface, and I can use the paste here. I'm gonna clone the whole existing repo from the cloud to your local computer. And because I already have this, so I'm gonna skip this command. And for you, if you have on computer, then you can go to the Bitbucket and then find the 18 SDLET time from the CWRU SDLE group, find this repository and git clone this. And for the people that you don't have the Git folder in on computer, you can use mkdir to create a new directory. For example, if I made a task folder, then you can see on here, I have a new folder, empty folder called tasks. That's the way you can use command line to do everything without using the mouse. And then after you get your if you clone your repo to your local computer, and you can show what repos do I have right now. So for my computer, those are the repos I have here. And I'm going to go to our SDLE time folder, and in the show what do we have here. So all the tea time materials and the reading stuffs are all in the topic folder. So you can also see from here in the gates topics. And for today's material are gonna be in the first week introduction to data science folder, and you can find all things you need here. For example, the cheat sheet I mentioned previously. And if you've done this, you can use Git checkout to see what branches you are, and also Git branch to see what branches do you have in this folder. So right now we have two branches. One is called master, and another called my own branch, where I can do my own changes and edits there. And you can also see from here that is represented is in my own branch. As I said before, we can switch to other branches. You can by typing the git checkout master. Then you can change to the master branch. You can notice that here's been that represents I move from my own branch to a new branch. And if I go back to my own branch, and you can also create a new branch locally just by git checkout B. Maybe we say a task branch, and then you can see it's gonna create a new branch called task and also switch you to the new branch. And then we can do git branch. You can see right now we have 3 branches. Also, if you don't want this branch anymore, you can use -d to delete this branch. Sorry, the checkout D. Okay. Maybe it's branch D. I need to go back to the master branch and delete this branch. Okay, so you can see after I delete them, we're gonna still have 2 branches here. So I'm gonna go to my branch to do some edits. Right now I'm in the topic, and I want to create a new folder, a new file called task file. You can notice I use Vim here. It's actually a text editor. It runs with Unix, and when you tap insert, it go to the insert mode. Then you can tap different, you can type the words in a plain text. So welcome to SDLE time. And after you're done with this, you can use escape and write. That means write and quit. You can save your edited file. So after I'm done with this, you can see I create a new text. Create a new text file here. And right now I want to put this to share with my team members. Then as I said before, we git add all. Here you can type all, which represents you want all the changes to share with your team members, or you can just select some. And also you can make just A means like a short term of all. And then we say git status. You can see I have something, a new file, and being added to the stage area. And then I can use git commit. M means message. When you do the commit, you want to have a message to tell your team members what's this commit used for and what the changes are. So my recommendation is the commit message to be short and precise, and also be uniform. So it's gonna be easier for people to rate. So here as a task, and like this, it's gonna check the status. If this thing, this local, this added file has been added to your local repository, and then I can git push. And I push this file to the to the cloud, and we go back. We can see the branches. It show like my branch right now is one commit ahead of the master branch, and if I think this is already I'm satisfied with this result, and I want to put into the stable master branch, then I can go to master branch to merge my own branch to the master branch. So I switch to the master branch and I do a git merge. In this way, I merge this branch to the current branch. You should notice that this git merge command is used to merge this branch to your current branch. So if you want to merge the different branch, you're gonna go to another branch first and do the git merge command line. And in this way, I merge here. That means lucky we don't get any merge conflict here. In this way, we can git push, transfer like the local changes to the cloud, and we can take a look at here. Then there's no active branches anymore. In the merge, I can see that those two branches are in the same pages, and that's good for us. And when you want to download and update your own repository from the cloud, you can use the git pull to get the updates from the last time. And because I think right now, because I'm already up to date, so there's no new updates here. But if you want to like work with other people, it's quite useful to do git pull every time when you start to the new work or the edits. And so I think this is mainly for the git. And close this and go back to our slides. As I said, I try to use a Vim. It's a text editor for Unix, and it's not only used because I just show how to use the Vim to edit a file or create a file. It's also actually very useful when you want to fix the bug from your scripts, because it has a strong ability to do the search by just typing a few keyboard keys in your keyboard. Here also have some useful links for learning Vim. For example, our SDLET time, that's a good resources pages for all of us, I think. Here you can go to scroll down and find those tutorials. It shows the information about how to use Vim, and also there's another tutorial. It's actually I think it's quite interesting. It's a communicative website, and it's gonna ask you to do some commands, and you're gonna learn how to use Vim fast. After you got familiar with Vim, it's gonna be quite easy for you to write your code and fix the bugs. And the next thing, I think we still have 15 minutes. I want to talk about Latex. So how many people have cloned the 18STLDT time right now? Okay, so if you are done this, you can go to the your local T-time folder and find one folder called W1 Latex example. And in this, and if you don't, you can also do right now. And in the meantime, I want to talk about something about latex based on my person point of view. I think latex is quite useful when I start to write the papers or the thesis. It's quite convenient than using the Word. The basic of the latex is just a document preparation system, and the contents of the latex is written in a plain text and can be annotated with various comments that describes how certain elements should be displayed for your documents. And there are several advantages of using the latex. The first one I think is about the flexibility of it. So currently they are overwhelming selection of packages that can simplify the complex tasks, and most of them are free. You can just use them simply. Okay. And another quite important advantage of latex is how that you can have a total control of your documents. I believe all of us have been frustrated by the words and the stupid interface. For example, if you want to position the image in your Word document, and you know that image gonna fit perfectly on the bottom of your document, but the Word just refuses to do that, and you're gonna waste a lot of time to finish this. But for latex, you can just avoid this. And also, another reason people transfer from Word to latex is the stability. I think the Word is quite possible to crash when you do some editing with Word. Also, it has ability to recover some documents. It's still recommend to use latex to save the life. And the most important thing about latex is it has a lot of advantages, and it's free. It's totally free like other open source softwares. And here also have some useful links for you when you use latex. You can go to the Share Latex website to find some useful basic information and comments here. And also another one is a Stack Exchange. That is where the most people ask questions here. And the last one is Google. Always to ask Google when you have a problem. And okay, right now I want to show some examples of how to write latex documents. The first thing you want to do is to tell the text. We are using the Text Studio to write latex documents. And the first thing you want to do is tell the Text Studio what the type of your document is. Here I made it the article. You can also make them like report, a book, a letter, or other different types. And before this, you can also set the font size and the paper for your for the print one. And here, after you've done this, let me make a new one. So I want to tell the document. And on this, you can just begin to write your documents. And another benefit of using the Text Studio is it can automatically help you to finish the code, the comments. Like I just have the document gonna ask, like help me to write the end documents, and all your contents will be written inside between this brackets. For example, I can just say, welcome to T. And you can knit this to a PDF, and then we're gonna generate a PDF file for you. And in this example that you should have from the SDOT time topic folder, I have a small documents I copied from the Wikipedia introducing the first book of Harry Potter series. And in this way, I think I show several types of way to edit your latex file. So first thing you want to know is how to make a title. When you type the title just by typing the using here, using this command, your title, and you will need this make title comment that's gonna put your titles, your authors, and the dates at the center of your pages. And also here for the date, you can type yourself. You can also use the today command to make it like the date of your PDF file. You can see here, and also go to here, gonna show the today's dates. And if we do like this, we can change it to another date, maybe 2020s, and comment this. You can see right now the date has been changed. And another way of making a title is using the begin title page command. In this way, you can change the title. They're gonna be in the same first slide without sharing the pages with other comments or other contents. Oh, I'm gonna put it here. You can see right now the title gonna be in this single page, and the other contents will be in other slides or pages. And when you start to write a document in Latex, the thing you're gonna use is called, for the different paragraph or the chapter, is what we call the section. We will automatically create this label for you, and this with the table of content commands, you're gonna create the content for you. Quite convenient and simple to use this. And for the abstract, which has different font size and the paragraphs formatting with other contents, you have another comment called begin abstract, and all the contents within this area or this environment will be formatted with the abstract formatting. And when we start to write, we can make those our contents more prettier by making them bold, underline, or emphasize some contents. So, for example, I want to make the author of this book to be bolded, and then I can use this comment. Or if you forgot this, you can also find from the left hand, from B represent the bold and the italics and the underline here. For example, if I also want to make this the first novel to be bold, I can add a comment here and put all the characters I want to be bolded in between the brackets. In this way, you can see the first novel in here already being bolded. And if you want to them both bolded or emphasized or underlined, you can use them at the same time. Going for this one, I use two commands together at the same time, so they can have the bolded at the italics at the same time. And another benefit of using the Latex as that is they have lots of packages. When you want to make your slides or documents to be more attractive, you can try to find different package and to incorporate those functions into your Latex documents. Here, I show an example of using the color package. And before this is the name of this package, and before this, I can also set some parameters for this package. And then I want to show the color and also the enumerate in my LaTeX documents by typing the atomize and also put the color here. In this way, I can change the color of different characters as I've shown here. Beside this, you can also use different package to define your own color by change the GRB coefficients that can create multiple different colors in your documents. And another thing is how to insert the figures in the LaTeX. Here I introduce the first. You start also with begin and to start an environment for your figure, and you tell the LaTeX where to find the figure in your directory, and also you can set the length, the size of your figure. Besides, may notice that I have a lower size h here that represents the position of your figure. You can change them by to different location. Maybe B represents the bottom of the figure. You can see I did this. It's gonna go to the lower side, the lower position of one page. And if you use H, that will put your figure the exactly same position as you mentioned in your LaTeX documents. And usually I just use H because the LaTeX can automatically help me to get the pretty format for my documents, and I kind of trust it. And another good way to use finger to format your finger in your document is to use different package. And here I want to show example of using the graphic package, which can do the similar thing for what we did in the Word. We can put those characters to wrap around this figure by changing the position. Here you can see L means left, it also makes R to the right, and C means in the center. You can change where you want to put the fingers in your documents. And in addition to the finger, one thing we would like to do is to insert a table. For the LaTeX is quite different with Word that how to insert a table. Here is an example how we make a table in LaTeX. We start with the begin table function to make an environment of the table. And then we can define how many columns we are going to use here. For example, right now I use 2 columns, and they're separated by a vertical line. And also I can add more vertical lines here to make it like more like a square. You can see it showing here. And also I can delete the center vertical line to erase this. You can also put more columns by typing the C or L or R. That's represent the center, the left, and the right, which means where to put your characters inside the table itself. And when you have the basic structure, you can just type the characters in the LaTeX. Here I want to show the ages of the main characters in the first book, and we all know they are all 11 years old, and then you can just type the character you would like to have, and then they're gonna separate it by this symbol that represents if we don't have this, they're gonna be an arrow, and all the characters are gonna be in the same cell. If we change to this, you can see the character and the age are in the same cell. And after you're done one line, you're gonna end up with a double backslash line that represent you finish this, and you're gonna go to another line. And also the H line represent you want to add a horizontal line here. You can also delete this to make this line erase this. And for writing academic reports, it's quite useful to type the equations. In the LaTeX, I know based on my knowledge, I know there are 3 different types of method to type an equation in a LaTeX. The first one is to use the $ to define a environment that you can type your math equation here. Also, you can have the backslash and the brackets that also have the environment for your equation. A third method to write equation is similar with the figure and table. You start begin equation environment and type the equations here. And also here I have a box function that's gonna change the characters here from math environment to the like the normal characters size or font or the format. If I delete this, you can see I gonna have them all in a math equations, and those are the and the last thing I want to point out is the reference. Usually when you have the want to write a report or a journal paper, you need to cite other people's previous work. And in LaTeX, it's quite useful to do this. You can have Zotero or other software can do the sorting of your journal articles or other documents. Or also you can go to the Google Scholar. And in the Google Scholar, whatever, like the topic you would like to choose, for example, I'm doing the PV, and you can find here, you can cite them with a big text, and then a bit slow, and then it can generate the big file for you. You can copy this into your big file, which is used to create a reference for your LaTeX. And here I have a small example of my big file. Those are got from the Google Scholar, and also you can get more detailed big file from Zotero. And I just need to give those informations, and here's the label of this bib item, and I use this label to mention in my contents, and I don't need to give them the number and the labels. It can help me to create those labels and arrange them in the order of what I mentioned in the main content, which can save a lot of time if you're want to edit your reference, want to add more reference or delete some. In this way, you don't need to worry about the numbers before your reference, and all of them gonna be shown in the order of your contents. Also, you can notice that in this, I wrote them in this sequence, but in the document I got, they actually have a different sequence. So it's quite useful for your writing documents with a lot of references and save a lot of time. And I think that's the end for today's tea time. Thanks for coming. And for tomorrow, we have R and R Studio. Alan gonna talk about the Digipot untidy words. And for you, you can go to this slide and find those links to install R and R Studio to prepare tomorrow's topic. And that's it. Thanks for attending today's topic. Are we done? Stop broadcast.